Hi, hello, welcome back to my YouTube channel. So, today I am going to tell you about binomial distribution has a limiting case of hypergeometric distribution. Okay, now, so in order to do this one, we have to follow two conditions. Those two conditions are first one, n turns to infinity, and the second one is m by n turns to p. So we have to follow these conditions. If we follow these conditions only, at that time hypergeometric distribution has a limiting case of binomial distribution. Okay, that means hypergeometric distribution turns to binomial distribution when capital N turns to infinity, m by n turns to p. Okay, now let us see how it happens. Okay, yeah, first we all know that hypergeometric distribution formula is p of x equals to mcx n minus mc small n minus x whole by ncn. Okay, and binomial distribution p of x equals to ncx p power x into q power n minus x. Okay, so this is binomial distribution formula and this is hypergeometric distribution formula. Now let us see. Okay, so mcx, in the sense we can write this one as ncx formula. Ncx formula is nothing but n factorial by x factorial into n minus x factorial. We all know that one. So m factorial by x factorial into m minus x factorial. Okay, in the same way this one, n minus m factorial by n minus x factorial into n minus m minus n plus x factorial. Okay, whole by, again ncn in the sense n factorial by small n factorial into capital N minus small n factorial. Okay, so now see here, these both are in denominator. Okay, it will come to here numerator. Okay, so nothing but a by b whole by c by d. If we have, how we can write ad by bc we can write, no? So in this way only we are going to write this one. Okay, so m factorial into this one, n factorial into n minus capital N minus small n factorial into n minus m factorial whole by x factorial into n minus x factorial, and next is m minus x factorial n factorial and n minus m minus n plus x factorial. Okay, so next that equals to, here if we see n factorial x factorial n minus x, all belonging terms we will write in the same place. First we will write the n terms, n factorial by x factorial into n minus, small n minus x factorial. Okay, next is m factorial by m minus x factorial. Okay, so and the next is capital N, we are having capital N minus small n factorial by capital N factorial, and the next is n minus m factorial by n minus m minus n plus x factorial. Okay, so now if we observe, this is nothing but ncx factorial. Here we have written ncx equals to n factorial by x factorial into n minus x factorial. That means in place of this one, what we can write? Ncx we can write, isn't it? So that equals to NCX. Now we want to cancel this one. If we want to cancel this one, what we have to do is we have to extend this factorial. Okay, so that means m into m minus 1 into m minus 2 and so on, m minus x plus 1, and the next term will be what? M minus x factorial. Okay, so like that. And the next what we are having is n minus n factorial we are having. Okay, so we'll write n minus n as it is, n minus n factorial. Okay, and the next is this one, n minus m factorial by n minus m minus n plus x factorial. Okay, so now we have to cancel this one. That means what we have to do is we have to expand this factorial. Okay, so that equals to denominator. I am writing the same. After that we'll expand this one. So denominator what we are having is nothing but m minus x factorial. Okay, denominator we are having m minus x factorial. So I have written here n minus x factorial. And the next this n we can write in this way. That means we can cancel this one also. So I am going to expand this one. N into n minus 1 into n minus 2 and so on. What we'll get is n minus n plus 1, and the next is nothing but n minus n factorial only. Okay, so now we are going to expand this one. Okay, so into, that means after this one the next step you can continue. Here I am not having place, that's why I am writing down. Okay, this is the same step. So n minus m into n minus m minus 1 into and so on. At last what we want is this one. That means before this step what we'll have? X plus 1 we'll have. So that means n minus m minus n plus x plus 1 into n minus m minus n plus x factorial whole by what we'll have here down? N minus m minus n plus x factorial. Okay, so now we'll cancel. See here, m minus x will get it gets cancelled, and this one also gets cancelled, and the next is n minus n factorial, and the next is n minus m, n minus x, n minus m minus n minus plus x factorial. We get, it gets cancelled. The rest of the term is NCX here m minus 1, m minus 2 and so on, m minus x minus 1 we can write now. Here m minus x plus 1 is there, no? So I am writing here m minus x minus 1, minus common I took here, into the next is this one, n minus m and n minus m minus 1 and so on, n minus m minus n plus x plus 1. Okay, whole by the remaining terms, n into n minus 1 into n minus 2 and so on, n minus common I am taking n minus 1. So this is the terms we are having, remaining terms. So now what we have to do is, so what are the conditions we took here? See, if you observe, the conditions are nothing but m by n turns to p. So we are having in this term only m. So that means what we have to do is, we have to divide with what? N. The whole term we have to divide with what? N, so that we can write in place of m by n p. So that's why I'm going to divide this term with n. So we'll get ncx is same we have to write. Next is, here we are having what? M. The first one is m we are having, no? So m by n. The first one is m by n. And the next is m minus 1, m minus 2. Okay, so that means this term I am going to divide with n. Okay, so next, m by n minus 1 by n, and m by n minus 2 by n, and so on. Okay, and the next is m by n, m by n minus what we are having here. If you see here, m minus x minus 1 we are having. Okay, so m by n into, sorry, minus x minus 1 by n. Okay, and the next is, till here we completed now. So, and the next is n minus m. Okay, so that term we have to divide with what? N. N by n minus, here what we are having? M. M by n. M by n into, so this one completed. Now we have to come to here. This is denominator, this is numerator itself. Now we have to divide this term with n. So that means n by n minus m by n minus 1 by n. Okay, and so on. The last term is this one. Okay, so n by n minus m by n minus n by n. So minus we are taking common, so that we'll get minus, this is one term only, no? N minus x. So this full term we are dividing with minus n minus x minus 1. We are dividing with n only. Okay, why? Because this is same term. Okay, so whole by, the next is this term, n into n minus 1, n minus 2, and so on, this one. Okay, so n by n into n by n minus 1 by n. See, this term, with this term I am dividing this term with what? N. Okay, so n by n minus 2 by n, and so on. N by n minus n by 1 by n. Okay, so this term. Okay, this is same term, so that's why I have divided with only one n. I did not split this one, n by n minus 1 by n. I did not split. Why? Because this is one term itself. Okay, so now what we have to do is, wherever we get m by n, there we have to keep what? P, so that as n turns to infinity and m by n turns to p, we get limit, first n turns to infinity, p of x equals to, here ncx. Okay, ncx limit n turns to infinity. Okay, m by n in the sense what? P we have to keep here. First we have ncx we have written, so now we are going to apply n turns to infinity limit. So m by n in the sense what? P we have to write, and the next is here also p minus 1 by n. And the next is p minus 2 by n. And so on. Again, m by n means p. P minus x minus 1 by n. Again, n by n in the sense 1. 1 minus p. Again, n by n is 1. 1 minus p minus 1 by n. Okay, and so on. Again, n by n in the sense 1. 1 minus m by n in the sense p minus n minus x minus 1 by capital N. So now what we have to do is by divided by what? Okay, divided by, here also n by n in the sense 1. Okay, 1 minus 1. 1 into n by n is nothing but again 1 minus 1 by n into n by n is 1 minus 2 by n and so on. Again, n by n is 1 minus n by 1 whole divided by n. Okay. So now NCX. So now what we have to do is limit n turns to infinity. So here 1 by n. N turns to infinity. So n turns to infinity is nothing but 0. So that means p again into p and so on. Here also we will get only p. Why? Because this becomes 0. N turns to infinity, no? So p and so on. Again here p. P minus what? 0. So all this will comes under p only. Now comes to here 1 minus p again and so on. Here 1 by n. 1 by n in the sense 0. So again 1 minus p again and so on. Here 1 minus p. Again this one becomes 0. So that means whole divided by what here? 1. Here 0. 1 minus 0 and so on 1 minus 0. That means here 1 into 1 into 1 is nothing but whole by 1. Okay. So now NCX, here how many p's are there here? We are having how many p's? P power x we have to treat. Why? Because x terms it will be. And here how many terms will be? N minus x terms, nothing but. So q power 1 minus p is nothing but q. Q power n minus x terms we have. So that means what? Here limit capital N turns to infinity, p of x equals to what? NCX p power x into q power n minus x. So in order to get this formula, what we did is n turns to infinity is first condition and the second condition is capital M by capital N turns to P. So how we know here we are having x terms and here we are having n minus x terms means nothing but here NCX depending on these only we can treat P is having x terms, q is having n minus x terms. So we all know that binomial distribution formula. No? So according to that also we can able to write the final result is this one. Okay, hope you all understand. And if you are newly watching this channel, please subscribe to my channel and please don't forget to like the channel. If you like, the video will reach to many students. So please like this video and share with your friends. Please like it. Okay, thank you. And don't forget to subscribe. Have a nice day. Bye. Take care.